Using exponential functions to model data. An exponential model is an exponential function or its graph that describes the relationship between two quantities for an authentic situation. That just implies that we have a real-world situation that we can refer to in many cases. So, exponential models. We say that two variables are are exponentially related if all of the data points for a situation lie on an exponential curve. So we have option A down below. They're exponentially related. All the data points lie on the exponential curve. We say that two variables are approximately exponentially related if no exponential curve contains all of the data points, but an exponential curve comes close to all of the data points. So option B there down below shows most of them are pretty close to our exponential curve, so we can just say that they are approximately exponentially related. Which graph gives a better approximation? So this is based on your point of view. To the left side, we have an exponential function. If we do a linear regression, we get f of t equals 0.14 times 1.065 raised to the power of t. Or on the other hand, if we do a linear regression, we get g of t equals 0.061t minus 0.64. Notice it's the same data, but based on your point of view, which one describes it better? Do be aware, there is no better or worse. In some cases, it becomes which one describes what you're trying to describe better. A linear equation or an exponential equation. So, suppose the flu epidemic has broken out at your school. Assume that on February 10th, a total of 20 people have the flu, and that each day the total number of people who have gotten the flu triples. Let f of t be the total number of people who have gotten the flu by the day that is t day since February 10th. A. Find an equation of f, and B. Find f at 4 and what is the mean in this situation. I highly recommend you read word problems at least 2 to 3 times. Read them 2 to 3 times will help you be able to depict what's important in many cases. Sometimes a few more times reading it may help. So let's try once again. Suppose a flu epidemic has broken out at your school. Assume that on February 10th, that's critical, right? A total of 20 people have gotten the flu. 20 people. Okay, on February 10th, 20 people. And they have gotten the flu, and that each day, the total number of people who have gotten the flu triples. Keyword there, triples. Let f of t be the total number of people who have gotten the flu. F of t is also key variable, I would say in this case. They want us to use the variable f of t, so f and t. Let f of t be the total number of people who have gotten the flu by the day that is t day since February 10th. Once again, t is a variable, it's important, and February 10th. Notice the wording since February 10th. That implies that it's started in February 10th, or they started noticing this on February 10th. Okay, so we know that February 10th, it started. So, day 0, agreed? If you started a stopwatch or start counting, this is the day you started counting, on day 0. And we also know that there were 20 people to begin with who have gotten the flu, agreed? So in that case, we can define this as the y-intercept. Day 0 is the t-value, which is the x representative, so 0. And then 20 people is the y-value of the y-intercept, or starting amount, initial values. So what else do we know out of this particular example? Triples. Yes, the word triples. Triples means 3 times, right? So 3 is the representative number. So keep in mind, we're trying to look for an exponential function. Right up at the top, we have the exponential function equation written out as f of x equals ab to the x. I highly recommend you write this formula whenever you're working on your homework at the top of the page. So each time you start a new page, write this formula if it's for exponential functions. So let's try to find out an exponential function then. Find an equation of f. Hey, f of x equals, hey, look at that. Seems like we actually pretty much have everything. F of x equals 20 times 3 to the power of x, right? Okay, so it looks like we knew the initial amount, that was the 20. And we have the v value, which means it triples, right? That's how it changes from the previous day. Each day it triples. So that's the v value. So we have the full equation then. Do keep in mind, the only thing that we're missing is convert that x into a t. Be aware of that. Go back to your reading and notice that they want us to use the t. So I highly recommend you change that x, instead of leaving it as an x, into a t in both locations. I'll leave it there for reference though. So f at 4 equals, they're wanting us to find the fourth day. By the fourth day, so that implies that wherever we see an x, or I should say a t in this case, I should have replaced it with a t, we need to have a 4. So f at 4 equals 20 times 3 to the fourth. Order of operations says we gotta do exponents first. So this is where your calculator could come in really handy, agreed? So on your calculator, let's try on your calculator, on button, very bottom. And we're trying to use the exponent. So 3, caret key, right below your clear button, and 4. And then hit enter, that should give us 81. Once we multiply 81 times 20, that should give us our full answer. 1620, 1620. Or otherwise we could have done it all at once. 20 times 3, then caret key, to the power of 4. And hit enter. If you have a T84, the only difference is it doesn't show your caret key, it instead raises it up for you into an exponent. But it gives you the same answer. And look at that. So in this case then, once again, 3 to the fourth gave us 81. 81 times 20 gave us 1620. By the fourth day, there were 1620 sick people from the flu, agreed? So that's quite fast. So in a sense, notice that it spreads quite quickly according to the exponential function. But what is February, or what is f at 4, I should say, before I give it away? This started on February 10th, agreed? So February 10th. Then the fourth day becomes February 14th, which is Valentine's Day, agreed? So be aware of that. There's a chance that Valentine's Day may affect the amount of people that were sick. Maybe it suddenly jumped or skyrocketed quite faster than before. So the triple value would not work anymore, in a sense, to represent the data. But it would represent the first 4 days, agreed? So there is our answer for this particular case. But let's go back real quick and a quick representation of what we originally had here. Notice that we have some data values that may not make sense towards the end there of both graphs, but there's a reason, or maybe a logical explanation, that they sort of had to be different, meaning real life happens and not everything stays the same the entire time, agreed? So be aware of that. Sometimes your data may not always be explained by the specific curve that you chose or linear equation that you chose, depending on the case. But once again, it's real life. So we don't expect it to always be exactly the way we wanted it.